Hi everyone, it's Asanali. So today I'm going to do a tutorial on Abaqus about a plate with a hole, right? So let's start with the part. So you click here on part. So I'm going to name it as a plate. It's a 2D planar, deformable, and a shell. So yeah, 200 approximate size and continue, right? So first of all, I'm going to draw my plate and then the constraint here. So the dimensions are 4 meter, and I'm going to give 10 meter with the length, right? So it's 10. So this is my plate. So now the hole on the center. So I'm going to draw a circle, and then I give the radius. So this is the radius, which is 1 meter. And then I'm going to put my circle on the center. As it was 10 meters, so 5 meters is okay. And then with the vertical here, it needs to be 2. So now we're fine, right? So I can quit here, and then I have my plate. This is the plate that I want to have. So now let's go directly on the property, and then you click here. So the material is going to be a steel. General density is going to be 7,900 because we are working on metal, right? So then elasticity, elastic, I'm going to give the Young modulus. So it's 200 power over 10, right? So then the Poisson ratio, which is 0.3, and now we finish with the property, right? So now I'm going to create a section. So yeah, it's section 1, solid homogeneous, and then you click continue here, and you activate the plane stress and strain thickness, right? So the thickness is 0.01 meter, and then okay. So the section we created, right? But we didn't apply yet. So now we are going to assign the property, the section on my plate. So I click here, assign section, and then you click your plate, then you hit done, and then you are going to click OK. So now we assign this section. So that's why we can see the change in color of my plate. So let's go on assembly. So we are going to create an instance, so you click and then OK, you're fine. I have my plate. So then let's go to the step, all right? So the step is an important thing to do because that's where you are going to define your boundary conditions or your loads, right? If you don't have a step, you cannot apply your load, right? So step 1, initial. So as we are working on a linear static analysis, so static general is okay, and continue. So now you go here, off the non-linear geometry off because it's non-linear, it's static linear, right? So it's off here. You can then incrementation, you go 0.5 and the maximum is 1. I think this is okay. And then you hit OK. So now you created your step. You can click here on the manager and you can check it, right? You have step 1. The initial is only, you can only use it for your boundary condition, but the loads you cannot. That's why we are creating a step, so then we can apply our boundary condition. So then you go on interaction. We don't have any contact, so we don't need to go on interaction. So let's go on load directly. So what I'm going to do is to apply a load. So it's a pressure, all right? I'm going to give a name. Let's apply a pressure. So here you click pressure, you hit continue, and then you click here. That's where you want to apply. You hit done and you give a value, which is minus 10,000. That's the pressure I'm going to apply. So you can see. So now we apply the pressure. So now the boundary condition. So I know I want to apply a fixed support. So I can go directly here, continue, and click here, done, and come below here, there is encastré. That means it's a fixed support. U1, U2, U3, you are 1, you are 2, and you are 3 are equal to 0. That means we fix all the degree of freedom, right? Whether it's translation and the rotations, all of them were fixed them. So we already fixed. So now let's go for the mesh, right? So for the mesh, we know that we have a plate, right? So I'm going to do two different studies. First of all, I'm going to do a large mesh so we can see the result. And the second time, I'm going to make a finer mesh. The finer mesh is the one that's going to give us results that are better, right? The results that need to really match our analytical solution. So first of all, let's click here. So we cannot, let's go on part here. So then I can. So approximate global size, I can go, for example, 5, and I hit OK. But I think 5 is much, right? So let's click again. So let's go 1, for example. So I go 1, I hit OK. So now let's go on start and check the type of element. Plan stress. This is the correct one because we have a shell material. So it's fine. So let's go here and generate the mesh. Yes. So now we have a mesh here. But we can see around the hole, we don't have a final mesh. So we expect to have results that are not very, very good. Okay. So let's go on job here and let's create a job 1 for the solution. So continue, okay, and then let's submit our work and let's wait for results. Now our results are completed, right? Let's say the simulation is completed. So now we can go and check the results here, and let's click here so we can see the value. So this is about 225 megapascal. So yeah, so this is 22,000 pascal. So this is the result that we have. And let's go and check the analytical results and see if they are matching, right? So here, our analytical results. So I prepare a Python code here, a syntax that I use all the information that we had in order to have analytical result. So I apply the Kirsch analytical solution, right? So we can see that they apply nominal stress, which is equal to the pressure that we apply was 10,000. So this is fine. This is me who just gave, but the one that we really wanted is the maximum hole stress, which is the stress around the hole. So here we can see that the analytical result, it's about 30,000 pascal. This is 29 kilopascal, which is close to 30, and it's 30,000 pascal. So that's what we expect to have on our simulation. If it's not 30,000, but we need to have closer results. So let's go back. So we can see here we have 22,000. So I guess the reason that we don't have 30,000 or results that are closer to 30,000 is because our mesh is not finer here around the hole. So this mesh is not correct. That's why we don't get better results. So let's go and find the mesh. Let's go and refine the mesh. So let's go here on mesh, and then I click this one, and I will hit here and click done, and I will give an approximate size, which will be 0.1. So this will give us really close mesh, right? So now I think from the side here, we don't really have to change anything because this is not that critical. But here around the hole, that's where it gets important. So let's go and generate the mesh right now. Let's generate. Yes, so now we can see we have a fine mesh around the hole. So we expect it to give us results that are closer to 30,000. So let's go here and run again our simulation. So let's create another one. So this is the job for the final mesh. So let's write final mesh. So we hit OK. And now let's submit our work again. So now we have results. Let's go and check them. So we can see it's 35,000. So I guess the mesh we can do better from the other side, because this one we have around 35,000. So this is more, I mean, these are better results, but we can still do better as well.